Hey guys, this is the lecture video for the equations of lines section. So the first thing that we're going to be talking about is how we find slope. Now we're going to find slope a couple of different ways, but the first way that we're going to work on it is using the slope formula. You can see here in the box that I've got, it says the slope of a line, M, represents the change in y over the change in x. Now what the slope of a line is, it's the steepness of a line. It's a measure of the steepness of the line, or some people refer to it as how diagonal the line is. You're going to be given 2 points, which we'll call x1, y1, and x2, y2. And then this is the formula that we use to determine the slope of the line, all right? M is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Be sure you put your y's on top and your x's on the bottom. I see a lot of people make that mistake, all right? Let's give this a try. All we're going to do is plug our numbers into that formula. Then we're going to do our our differences on top and bottom, and then if we can reduce the fraction, we will, but slope is very commonly left as a fraction. Usually an improper fraction, you don't see slope expressed as a decimal very much. If you're talking just strictly about slope, we also don't see it represented as a mixed number, okay? So we're going to use a fraction, even if it's improper. All right, so let's take a look at the equation, or not the equation, but the problem that we're looking at here. This is actually question 2 from your homework. And I've got your homework off to the side over here. So I'm going to show you as we go how you enter the answers. 1 and 2, 3, and for some reason it's not letting me scroll on down from that. I probably clicked in something. 4, let me scoot it over a little bit. All of those problems, those are all the same type of problem, okay? So they'll all be worked the same way. All right, so I've given 2 points. It says determine the slope of the line passing through the points 7, -7, and -3, 4. So I'm going to label my points x1, y1, and x2, y2. Now I do that just so I don't lose track of what numbers I'm plugging in where, okay? And then our formula is m is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So we plug those numbers straight into the formula. My y sub 2 is 4. And y sub 1 is -7. So since we're plugging a negative into this formula where I have a negative in front of that number, those two negatives are going to go together to be a positive. So we wind up with 4 plus 7 on top. And then in the bottom, -3 minus 7. Okay? And now to simplify that, we just combine terms on top and we combine the terms on the bottom. So we're going to get 11 over -10. All right. And let's pull that negative out in front. There's really nothing improper about leaving it in the denominator, but I like to have mine out in front of the fraction there. All right. So we're going to enter our fraction as a fraction. Okay. As I said, we're not going to do a decimal. Let me scoot this over a little bit since it seems like it's acting a little wonky if I have it too small. All right, so I'm going to be typing in a fraction. I'm going to go ahead and put the negative sign in, okay? And then I'm going to choose the fraction off of our little math pad there, and we type in 11 on top, and then I'm going to touch and select the bottom. If you're on a computer, you'll click. But I'm on an iPad, so I touch down there and I select the bottom. And be real careful, make sure you click outside the box, okay, to clear out your cursor, and that way you don't accidentally put extra stuff in the answer, okay? We'll double check it again just to make sure it's the right one, and then we hit submit question, and I've messed something up. Great. Okay. Oh, I put it in question 1, sorry. Ignore me. Duh. Okay. So in question 2, -11 over 10. Oops. See what I was talking about accidentally touching inside the box and getting extra stuff in there? I've put an extra exponent in. Okay. Now, there we go. It helps to get it in the right question box, okay? So that's the way you will do question 1. You'll just do it with your numbers and not mine. And then 3 and 4 also work that exact same way, okay, with that formula. Now, before we move on to something else, I want to show you something about finding slope if you don't have 2 points. If you have the equation instead of your coordinate pairs, if we have something called slope-intercept form. Slope-intercept form is written y equals mx plus b. And in this form, m is the slope and b is the y-intercept. Okay, so if you can get the equation into that form, you can find slope just simply by looking at the number that is the coefficient on the x term. All right, if that number is positive, then you have a positive slope. Positive slopes actually give you lines that go up to the right. Negative slopes give you lines that go down to the right. And we'll see that in action a little bit later on in the semester when we're looking at increasing and decreasing functions. Okay, let's move on to our next thing, which is horizontal and vertical lines. I just want to talk about this really quickly. You don't actually have a homework problem on this, but we do need to take a look at it because sometimes when you're calculating your slopes, the slope is going to wind up being either 0 or undefined. And when that happens, you have a horizontal or a vertical line, okay? So if we have a horizontal line, that line's parallel to the horizontal axis, okay, which means that it does not cross the horizontal axis at all. So it does not have an x-intercept. It doesn't cross the x-axis anywhere. And its slope is equal to 0. Now the reason why is if you take any 2 points on any horizontal line, we'll use this as an example right here, and you plug those 2 points into that slope formula that we just got through talking about, the y values of both points will be the same number. In this case, that number is -2. And so your numerator will be 0 of your slope, and that's going to make your slope equal to 0. Every single horizontal line has a slope of 0. Every single horizontal line also is written with the equation y equals b, where again, b represents the y-intercept. It's where it crosses the y-axis, okay? It's also the only y value that you'll have for that entire horizontal line. They all have the same y coordinate, so it's pretty easy to pick out that number. Then for a vertical line, the slope is undefined. Or in this case, if we're working on My Open Math, the slope is DNE, does not exist is what that stands for. And that's how you'll, that's what you'll use to indicate that your slope is undefined when you're working through the problems, okay? Now what happens with an undefined slope is as you are calculating M, you'll get some value on top. It really doesn't matter what. We'll just say 3 for the sake of having a number there. But then you'll get a 0 on the bottom, okay? We can't divide by 0. And so anytime you get 0 in the denominator of a fraction, that means that your value does not exist, okay? The formula for a vertical line is always x equals some number. We'll call it a, but it's actually the x-intercept. If you look over here at the graph that I've got, this graph right here, this is the line x equals -3. It's a vertical line coming down through -3 on the x-axis. Just like with a horizontal line having all the same y values, vertical lines have all the same x values. That's why we use it to write the formula. Okay, another little couple words about slope. Let's talk about parallel and perpendicular lines and their slopes. The first illustration that you see here, this first graph, is a set of 3 parallel lines. Now, lines that are parallel are lines that don't ever cross each other. The only way that can happen is if the slope, as rise over run, okay, the change in y over the change in x, is the same for the lines. And if you look at the set of equations that goes with these 3 lines that are right here, what you notice is all of the x terms are the same. All of the slopes, the M values are the same for all three lines, okay? So it's really easy to tell if two lines are parallel by comparing their slopes to each other. It's also easy to find a line that's parallel to another line by using the slope of the line that you know to help you write the equation of the line that you're trying to find, okay? For perpendicular lines, if we look at these two right here, these are perpendicular lines. They are angled with each other. Let's zoom in on that just a little bit. They're set at an angle. They do cross each other, and they cross specifically at a 90-degree angle, okay, or a right angle. If you look at the two equations of the lines that we have here, the slopes of those two, we have 3 as the slope of the red line and then negative 1/3 as the slope of the blue. And if you kind of think about how those two numbers are connected, for one thing, you'll notice that they're opposite signs, okay? Parallel or perpendicular lines will always have opposite sign slopes, and the slopes are also reciprocals of each other, okay? So we say that they have opposite reciprocal slopes. So let me move this down just a little bit so that we can take a note right here. We'll say parallel lines have the same slope. So you look at the slopes and compare them. If they're the same, they're parallel. And then perpendicular lines have opposite reciprocal slopes. So they'll be opposite in sign and they'll be reciprocals of each other. Now, in your homework, the way that we are looking at this particular relationship is you'll be given a couple of lines, and there's two different ways that this is presented in the homework. One way, you're given the lines by being given 2 points on the line. That's the one you're looking at right here. And in the other way, you'll be given the 2 equations, okay? The equation ones are actually a little bit less work than these, but these are first in the homework. So we'll talk about them first. All right, so consider the following 2 lines. Line 1 passes through the points 5, 17 and -5, -3. And then line 2 passes through 2, 0 and -1, 9. All right. First, it asks us for the slope. So we need to calculate the slope of these 2 lines using the formula for slope. And then it says, finally, which of the following is true? So we're going to have to find the slopes and then compare them to see if we have parallel lines, perpendicular lines, or neither. Those are the 3 options that we could have. So let's go ahead and find our slopes. We'll start with the one for line 1. I'm going to call it M1. All right, remember it's y sub 2 minus y sub 1. So that would be -3 minus 17. And then on the bottom, it's x sub 2 minus x sub 1. So -5 minus 5. And that gives us -20 over -10, which will reduce to a +2. Okay, so that slope's going to be 2. I need to pop that up over here so we can go ahead and put that in. Oops, I typed in the wrong blank again. All right, so that's going to be +2. Now, let's figure out what the slope of the second one is. So I'm going to call it M sub 2. And it's going to be 9 minus 0, y sub 2 minus y sub 1, over x sub 2, -1 minus 2. Okay, so that is 9 over -3, which is -3. Okay, so these two are not the same, and they're not opposite reciprocals. So that tells us that this particular set is neither. I'm still putting these in the wrong place. Let me go down here and find where my numbers are. Okay, so we had 2 for the first slope, and then -3 for the second. And what that tells us is that line 1 is neither parallel nor perpendicular to line 2. I'm just doing that one in the middle. So when I submit this, we're going to have some red X's for the other 2 parts of the problem. but the one that we worked on is correct, okay? So if you get 2 and 2, the lines would be parallel. Or if I had had 2 and negative 1/2, then they would have been perpendicular to each other. But since I have 2 and negative 3 is kind of a random number there, there's no connection between those two. And so we're neither parallel nor perpendicular. Okay, let's move on to the next question. Now this one is asking the same question, but instead of being given 2 sets of points, I'm given 2 equations, okay? So what we need to do is find that slope intercept form so that it's really easy to tell what the slope is from both of these. And remember, all we're doing is heading towards the form y equals mx plus b. And so what you really have to do here is solve for y, okay? So that's what we're going to do. We'll take our first one there, 3x plus y is equal to 1, and that's going to be real easy to solve. We need to move the 3x, right? Because we want to isolate y on this side. So what we do is subtract that term from both sides, and y is equal to negative 3x plus 1. Okay, so that's going to be our slope, negative 3. We'll talk about that in a minute. Let's go ahead and get our slope for our other equation. Okay, so what we do here is solve this for y. All right, so I'm going to solve first for 18y by taking the negative 6x and moving it. We'll add 6x to both sides. And I'm going to go ahead and set it up over here where it's in the right order, just like I did the other one. 18y is equal to 6x minus 4, and then I need to divide through by 18. We'll just go ahead and write it down right here because that will give me just a positive y. All right, if I simplify that, y is equal to, 6 will go into 18 3 times, so that reduces to 1/3 x, and then 4 over 18, that will reduce to 2/9. Okay, the constant part of this is not all that important because of what we are looking for, okay? We want to know whether these are parallel and perpendicular, so we're focused a little bit more on the slope. We'll call this one M1, that's negative 3. This one's M2, it's positive 1/3. So if we compare those two, one of them's positive and one's negative, and they're reciprocals of each other. So that is an opposite reciprocal slope, and that means that we are perpendicular, okay? So let me move back to the homework down to number 8. And you'll notice that questions 6, 7, and 8 are all this same type question. So you'll work 6 and 7 the same way. Okay. And looks like question 9 is also that same. Well, there's several more. Never mind. You have several after that, 9, 10, and 11 that are all asking you to tell if they're parallel, perpendicular, or neither. Okay, let's go to our last type of problem that's in this section. Now, these are the longest problems in this section. They require the most amount of work of anything else that we've done. What we're doing here is we're finding the equation of the line. Okay, so we're going to be given a little bit of information about the line, and we're going to have to figure out what the equation is from that information. The formula that we use for that, let me slide this back a little bit so y'all can see it better, is called the point slope formula. And this is it right here. Okay, y minus y sub 1 is equal to m times x minus x sub 1. Now the m here is slope again, okay? And then your x1 and y1 come from a point, just one point on the line. So as long as we've got slope and a point, we can use this to find the equation of a line. So there's several different ways that this could happen, okay? You may be given slope. It may just be handed to you in the equation. We're going to do one like that. You may be given 2 points on the line and have to calculate slope using the slope formula, or you could be given a line parallel or perpendicular to the line that you want. so that you can find the slope of that line and then figure out what the slope of your line is supposed to be based on whether it's parallel or perpendicular, okay? So we're gonna do one of each of the two that you guys actually have in the homework. You have some where you're given the slope and a point, and then some where you're given 2 points, but I couldn't find any that had the perpendicular and the parallel. So if y'all run into one in the homework that I just missed, you can let me know and I'll run through one of those for you too. Another thing I want us to talk about as we flip through the different questions here in just a second, some of the questions do ask for the equation written in a certain form, okay? Some of them want you to write it in slope-intercept form, and some of them you actually could, or it wants you to put it in point slope form, and then some of them actually doesn't make any difference, okay? So we'll run through those. Just be sure you read the instructions carefully, and it shouldn't be a problem figuring out which one's which. All right, let's start with the one right here where we are going to find the equation given a point and the slope. So since we have everything already that we need, we're given all the pieces, I'm gonna go ahead and come in here and label the point. This will be x1, y1, okay, and we already know m's already labeled for us. So we'll start out with our formula, y minus y sub 1 equals m times x minus x sub 1, and we plug our numbers in. So y minus negative 20, okay, because negative 20 is our y sub 1, is going to be y plus 20, is equal to, m is 8 for this problem, and then x minus x sub 1, which is negative 2, so x plus 2, that's what we get there. Now you want to go and if the problem is asking for point slope form and says don't simplify it, then that's where we are right now, okay? This is point slope form, and it has not been simplified. Okay, so if that's what you're asked for, and you've got at least one, I know, you've got one, question number 12, the very first one of these questions, you can leave in that form, okay? And then some of the others will take it as well. But if you need to go farther, if you need to get slope-intercept form, here's what you do. We start by multiplying here. We want to distribute the 8. So y plus 20 is equal to 8x plus 16. And then we want to subtract 20 from both sides, okay? And that will isolate y, and so we'll have the right form at that point. This is really pretty easy unless you have a lot of fractions to deal with. If we subtract 20, we get negative 4 there. So y is equal to 8x minus 40. I'll come over here and put that in. I don't remember which one I got this from. This was question number 13. If we look at question number 13, it says determine the equation of the line passing through the point negative 2, negative 20 with a slope of m equals 8. And then it's got equation of the line, and then it's got a blank for that. So we'll put the whole equation in there. And that was y equals, and my keyboard's covered up the rest of it, so I'll double check it before I enter it, but I think it was 8x minus 4, 40. That would have been bad. Okay, and see again, I'm not even touching near the box, but it's still kind of picking it up. So be careful where you click. Okay, didn't like that. Maybe it won't sit. Oh, I'm stupid. All right, guys, if you go back over here and look, I messed up. And I don't know why I did that. 16 minus 20 is negative 4, duh, instead of negative 40. I had it right when I typed it in, but I looked back at it wrong, so I apologize. Careless mistake. Okay. And that is our slope intercept. Okay. Question number 14 there, I'm not going to work it, but it does, I don't think I have it. No, I have 19. Okay. It already has a y out in front of it, so it's pretty safe to say that on question number 17, it wants you to put it in that slope-intercept form, since it already has the y sitting out in front of it with an equal sign. So you won't have to retype y on 17. 18 is like 16, where you can give your answer in point slope form and you don't have to simplify it. You can just type it in as you get it there. And I kind of played around with that to check to see if you could get away with doing some simplification, and you could, okay? So if you forget and go ahead and distribute your slope, I think you'll be all right on those two. Now 19 and 20, they asked for both forms. Okay, so that was the next thing that I wanted to show you. And this question also is finding the equation of the line given two sets of points. So we'll have to find the slope using the slope formula and then use point slope form. Okay, so the first thing that we'll do is find slope. This is x1, y1, and x2, y2. And the formula for slope is x2 minus x1, I'm sorry, y2 minus y1 over x2 minus x1. So 2 minus 8 over negative 10 minus a negative 7. So we get a negative 6 on top, negative 3 on bottom, which will reduce to give us positive 2. Okay, so that's our slope. And what we'll need to do is choose one point or the other to plug into point slope form. I'm going to take the one I already have labeled, x1, y1, okay? There's no reason to switch to the other set, so I'm just going to go ahead and use the one I've already got labeled. So it's y minus y sub 1 is equal to m times x minus x sub 1. That's going to go into your point slope form blank, okay? Because that's what we've got first. That will go into point slope form. And then you'll go ahead and solve it for y to get slope intercept. So let's do a couple of steps here. Distribute the 2x plus 14. And then add 8 to both sides. So y is equal to 2x plus 22. Okay. Let's plug those in just to make sure that I hadn't made any mistakes on those two. All right, so y minus 8 equals 2 times x plus 7. Two times x plus 7. That looks really weird over there, but maybe it'll be okay. Our little box didn't pop up, so I may have to make sure that y is lowercase. I'm on my iPad, and so I've got that weird caps lock thing going on. There we go. And for slope intercept form, it was y equals 2x plus 22. And there it goes again. 2x plus 22. Okay. And I didn't make any mistakes on that one, so we're doing good. All right, that covers all the different problems that you'll see from the homework for this section. That's it.